Yes.
There was someone who was saying something. I couldn't hear them well. What were you saying?
So I was asking if you are recorded.
I am recording. Thank you for reminding me. In terms of oxidation number. Sorry, let me. In terms of so these are our subtopics. We are going to start with the first one. We're going to start with the first one. We're going to scrutinize it, define redox, go on to the second one, the third one, and the last one. Any questions before I proceed?
No, sir.
Thank you. We do have the first definition in terms of oxygen. So I'm going to divide my page into two. Okay? This side I'm going to do red. Let me use red for red. Red. Reduction. And then this side, oxidation. You get it? Remember, this is the first definition in terms of oxygen. In terms of what? Oxygen. So reduction is loss of oxygen. Reduction is what?
Loss of oxygen.
Reduction is loss of oxygen. While oxidation is what? Oxidation is gain of oxygen. Let me give you an example. If we have an equation carbon plus oxygen, what do they give me? They give me carbon dioxide, isn't it? Ma?
Yes, sir.
Carbon dioxide. So if you have such a reaction, carbon plus oxygen to yield carbon dioxide, from carbon to carbon dioxide. Wait, sorry. Wait a minute. Carbon, oxygen to carbon monoxide. Okay, let me say carbon monoxide. So this is incomplete combustion of fuels. Okay, it's called what? Incomplete combustion or incomplete burning of fuels. Okay, when there's not enough oxygen, the oxygen was not enough. The oxygen was not what? Not enough. Okay, when the oxygen is not enough, we say that there is an incomplete combustion. Therefore, we produce what? An acidic gas. This is a carbon monoxide, which is what? Acidic. So from oxygen, which is O2, to CO, you see we have lost oxygen here. We have 2 oxygens here, and here we have 1. So there's loss of oxygen here. So which means this process is what? This process is reduction. The process is reduction because there was a loss of oxygen. Rather, we can have a similar reaction. Carbon plus oxygen. In this case now, this is enough supply. Enough supply. As long as there's enough supply of oxygen, we are going to completely burn the carbon, and then we produce carbon dioxide. So which means that carbon to carbon dioxide, because there is a gain of oxygen here. We call this one what? Oxidation. We call it what? Oxidation. Guys, are we clear?
Yes, sir.
No, sir.
Who is left behind? Hello? Guys, are you with me?
Yes, sir.
Okay. If you're left behind, let me know, okay?
Yes, sir.
We are going to do what we call reducing agents, okay? We're going to do what? Reducing agents. Are we clear? Reducing agents. What are reducing agents? Hello? Can I rub off? We have what you call reducing
Yeah.
agents, and then you also have oxidizing agents, okay?
Yes.
What are reducing agents? What are oxidizing agents? Reducing agents are those which are oxidized, the ones which gain oxygen, okay? The ones which do what?
Gain oxygen.
Those that gain oxygen. And then these ones, they are the ones which lose oxygen, okay? Oxidizing agents are the ones which what? The one that loses oxygen. In a reaction, remember, we are still on the first definition in terms of oxygen. When you see a reaction whereby there's loss of oxygen, just know that the one which lost oxygen is a oxidizing agent because it gave away oxygen. In other words, they're called givers of oxygen, okay? They're called what?
Give us
Well done.
oxygen.
Can I give you examples?
Yes.
Examples of oxidizing agents and reducing agents. Anyone who knows? Let me give you a list. The list is endless. Oxidizing agents that you know. All oxides, okay? All what? All oxides. Give me an example. CO2 again. CaCO3, Fe2O3. Those are other examples of oxidizing agent. We have oxygen gas, which is called O2. Oxygen gas is called what? O2 again. I think you are alone. Lantokomolo.
Data.
So I can add.
No, Sorry.
Other oxidizing agents that you know. We have acids, okay? We have what?
Acids.
Acids, e.g., sulfuric acid, phosphoric acid. This and then we have others. Which others do you know? We have O3. O3 is what? Ozone. Again. It's called what?
Ozone.
We have halogens. We have what?
Halogens.
Can you give me examples of halogens that you know? We have Br is what? Bromine.
Bromine.
F2 is what? ETC. You get it?
Yes, sir.
And then we have reducing agents. Reducing agents, they are the gainers of oxygen. Okay? They are the what?
Gainers of oxygen.
Give me examples. We have hydrogen. We have carbon. We have carbon monoxide. We also do have metals like magnesium, potassium, lithium, and so on. Again, iron, zinc. In short, we can say alkali metals. Okay? We can say what?
Yes. Alkali metals.
Alkali metals. So you should be in a better position to know this. Are we together?
Yes, sir.
Okay, let me give you an example of one redox reaction, and then you should be in a better position to identify the reducing agent and the oxidation agent, okay? And the half reactions. Can I rub?
Yes, sir.
With your permission?
No.
Clear
Wow.
all. Oh. Shabali. Equation number 1. Which equation can you use? Do you know the equation here? Equation for Aluminium plus oxygen, what do you form?
Aluminum oxide.
Aluminium oxide. Okay.
R.
Who is that? That boy is intelligent.
Kidney.
Aluminium plus oxygen, you produce aluminium go on again.
R.
So in this case, we have two half reactions again. The first one, half reactions. Half what?
Reactions.
Half reactions. The first one, Al2 Al2O3. Again, what happened to aluminum there? Did it lose oxygen or it gained oxygen? Ma?
It gains oxygen.
It gained oxygen. So which means this is an oxidation reaction. Again, it's a what?
Oxidation reaction.
Oxidation reaction. And then we have reaction number 2, half reaction number 2. It is O2 to Al2O3. What happened to oxygen then? Did it get lost or it gained? It got gained or something. It lost its identity again. Because it existed as an independent entity. Now it's now existing as a compound. So this is the reduction. Okay? This is what?
Reduction.
Let me give you the last example. Hydrogen sulfide plus chlorine. Okay? You're going to produce sulfur plus hydrogen chloride. Again,
Hydrochloric
your
acid.
reaction are they? Ma? Hello? Isn't it?
Retire.
H2S to S. That's the first half reaction. The other one is Cl2 to HCl. Again, remember that halogens are also oxidizing agents. Again. So in other words here, let's start with chlorine. Chlorine to this. This is reduction. Again. This is what? Reduction.
Reduction.
From Cl2 to HCl, there's loss of chlorine here. So this is reduction. And automatically, if this one is reduction, this is oxidation. But let me not define this oxidation because we are going to point number 2 of defining oxidation. Oxidation in terms of electrons.
Hydrogen.
Okay? Oxidation in terms of electrons. Raul.
Yes, sir.
In terms of electrons, okay? So this is how you define redox. You define it in terms of electrons by a simple term called can you read this term for me?
Oil rig.
Is it your first time hearing such?
No.
Let's start with oxidation here. Oxidation. And then reduction over here. We are going to differentiate the two. O here. Oxidation is loss of electrons, okay? Is loss of electrons. Reduction is gain of electrons. Remove. Are we
Yes,
on the
sir.
same page, guys?
Yes, sir.
Thank you. So I'm going to, Lipu, you want to ask a question?
No, sir, it was a mistake.
Thank you. So I'm going to give you a few examples of loss of electrons. For example, remember, according to our periodic table, we say that metals lose electrons to be positively charged. Again, right? And non-metals gain electrons to be negatively charged. So in other words, metals undergo oxidation. Can you write that one down? Metals undergo what? Oxidation. We say that metals lose electrons to be positively charged or to form cations, cations, whatever you call them. And non-metals gain electrons to form anions. Okay? So the conclusion is that
Yes, sir.
metals undergo oxidation because we say oxidation is what? Loss of electrons. While reduction is gain of electrons. Do that make sense?
Okay. Yes, sir.
Who is busy with inbox during lessons?
Your Honor.
So let me just do a half fraction here. Let's say you have K. K is what?
Potassium.
Huh?
Potassium.
Potassium.
Potassium. It's in group what?
Potassium.
What group is this?
Is it 1 and 2?
It's group 1, okay? It will lose an electron to be. So what is this? This is oxidation, okay? This process is called what? Oxidation. Because it's loss of electron. Again.
Yes, sir.
What about if you have chlorine ion gains an electron to be chlorine What is this?
Reduction.
Reduction.
Wait. I get the lesson. So this is a reduction, okay?
Yes, sir.
So
Yes, sir.
let me just do one example of a reaction, of a full reaction. Okay, of a what?
A full
Of a
reaction.
full reaction. Just one. Are we there? Let's say sodium plus chlorine, okay, to form sodium chloride. I get sodium plus what? I get it. Sodium, it's Na, it's a solid. I get plus chlorine, which is to form sodium chloride, which is aqueous. I get. Right, guys.
Yes, teacher.
Error.
This is a gas. I get. So the two have reactions. The other one is sodium to sodium chloride. I get it. And then the other one is chlorine to sodium chloride. So remember, this is sodium 0. I get it. Is sodium what? Do you hear what I'm saying?
Okay.
No,
How
sir.
does sodium react? How does sodium react? It loses electron. Again. Remember, this is aqueous, okay? So which means it has Na plus ion here plus Cl minus ion. Do you understand what I'm saying? Huh? So which means this is from Na to Na plus. Again, because it was a solid state. It was on a solid state. It lost its one electron to be an ion. It exists as an ion in a solution. So which means there is loss of electron here. When there is loss of electron, there is what? Is oxidation. Do you get what I'm saying?
Yes, sir.
Yes, sir.
And then the one which loses electron, or the one which gives up oxygen, or the one which is oxidized, it's a what? It's an oxidizing agent. So which means this is a what? Oxidizing agent. And then this one, from Cl2, which was more stable as a gaseous form, from Cl2 now to what? To Cl minus. Again, remember it's a non-metal. It gains one electron. The one which was, remember these are ionic equations. They exchange valencies. It gained one electron which was donated by sodium. So it gained how many? An electron. Again, from sodium. So which means from 0, from a gas to a solution. So which means this is reduction, because we say rig. From the term rig, this one we get it from the word From the term what?
Reduction is
Reduction is gain of it gain an electron to be an ion. So which means this is reduction. Okay? So the one which is
Yes, sir.
reduced, it's a the reducing agent. It is the one which is oxidized. The one which is reduced is a oxidizing agent. Ladies and gentlemen, unfortunately, that's where I'm going to end. I'll continue the rest on Thursday.
Bwana Majda. Lagi boleh zoom muda ya kita gitu yang Malaysia ni. Yang mana?
Yo, what's wrong with this one?
Thank you very much. Any questions?
Sir, are you saying our next lesson is on Thursday?
Our next chemistry lesson.
Oh. Okay.
Bwana kaba kabat tahu gua.
I'll see you tomorrow, guys. Tomorrow we have physics, okay?
Who was speaking right now?
Tomorrow,
So
hello.
Nuri,
Tomorrow I'll be teaching waves on physics, okay? I'll be teaching what?
Bwana.
Khutlana
Kimana
kwa
50 pula.
kama
Kimana
pente,
50 pula
say.
mo arrange manina bana.
Bora, vejo se
Tô
que
com
te
50 pula mo
pi, que te
arrange
pila
man.
kamanje. Mr. June. Mr. June.